Hello everyone, this is Marvin Pidakan and today I will discuss our laboratory examining the plugs in the status register using AVR Studio 4 with ATMega32 as our device. So I have written my codes here based on the given problems and now we are going to simulate these codes to examine the status registers. So I use the LDI instructions and the add instructions here as per the problems. So we're going to load the hex value 92, hex 23, hex 66, hex 87, and the hex F5 to the registers, and then we will add it using the add instruction. So let's try to simulate this. As you can see here, the SREG, it is the short term for status registers. So the status registers is an 8-bit register which is the flag register in my AVR microcontroller. So as you can notice, these 8-bit registers have corresponding flags. The carry flag, the zero flag, the negative flag, the overflow plug, the sign flag, the half carry plug, the bit copy storage plug, and the global interrupt enable plug. But only 6 of these are called the conditional plugs, wherein it can be used in conditional branch. For example, if we desire to create a loop in our microcontroller. Now, I will simulate these codes to examine the status registers, but we will only focus on the C plug, H plug, and the Z plugs as per the given problem. Also, I have used the LDI instruction to load immediate the value of hex 92, hex 23, hex 66, hex 87, and hex F5. Also, add instruction is being used here to perform the addition operation. And the R jump or the relative jump is being used since it uses less memory space in the microcontroller. To simulate, I will just need to click the step into or the F11 continuously since we already know that the LDI instruction will load the immediate value into the registers. Also, I have prepared here a solution. First, I convert the hex values into binary so I can perform the addition. So as you can see here, there is no half carry between D3 and D4, and also there is no carry at the D7, and the result is not 0. So we will expect that the status registers here, the carry plug has a value of 0, the 0 plug has a value of 0, and the half carry plug has also a value of 0. So next, by clicking F11, so as you can notice here, there is a value of the C plug, which is 1. It indicates C is equals to 1. So as you can see here, in my computation, when we add the result here, because this is the new value of the R20, we will add this to the value of R22. So as you can see, D0, D1, D2, D3. So at D4, there is no carry for the half carry. So half carry will be 0. And the carry here at the D7 So C is equals to 1, which is correct as we examine the status register here. So next, F11 again. The C flag has a value of 0, 0 flag 0, half carry flag is 1. So we will check this in our solution. So at D0, D1, D2, D3, and D4. So there is a half carry flag. And at D7, there is no carry here. So the C flag will be 0. Okay. So the status register is correct. Next is the C flag here equals to 1. 0 flag here equals 0. And the H flag here is 0. So as we look at the solution, there is a carry in the D7. So C flag is equals to 1. And then the result, since it is not 0, the 0 or the C flag will be equal to 0. And you can also notice here that there is no half carry flag between D3 and D4. Next, we will discuss the second problem. So we are given here the code, and we are just to examine the flag and the register content after the execution of each instruction. So just click F11 or step into. So the LDI here, LDI R20 hex 27. So 0x27 is loaded immediately to R20. Next, hex 15 is loaded immediately to R21. Then the sub instruction, we will subtract this R20 and R21. So here's the result. And as we can see here at the status register, the carry flag is 0, the 0 flag 0. This important flags here, the 6 flags is 0. So I will just focus on this flag. So as we can see here in our solution, there is no half carry at the D4, and there is also no carry for the D7, and the result is not 0. So the status register is correct. Next, we load hex 20 into R20. So the new value of R20 is 0 hex 20, and we load hex 15 to R21 here. Then we will subtract again R20 to R21. So let's examine the status register. The half carry flag has a value of 1. So in the solution, we will expect that there is a carry over in the D4 for the half carry flag. So as you can see here, D0, D1, D2, D3, and D4. So there is a carry, a half carry flag. So at D7, there is no carry flag. There is no carry. So the value of C flag is 0. And the result is not 0. So the 0 flag or the C flag is 0. So check. Let's move on. Now we load 95 in decimal. 95 in decimal to R24. And again, we load 95 in decimal again into R25. So here, you will see at the register, it is the displayed here is the hex value. So I will show you the when it is in decimal value. So ayan, it is 9595. Okay, let's move. We subtract R24 and R25, and we store the value at the R24. So 95 minus 95, 0. So this is correct here. And then the status register here, the 0 flag is 1, since the value after the subtraction is 0. As you can see here in our solution, uh, yeah. So the result is 0. There is also no carry here. So next, we load 50 and decimal into R22 and 70 in R23. 70, 50. So now we will subtract R22 and R23. So the result will be stored at R20, R22. So it must be 20 with the value is negative. So we will look at our solution here. So there is no half carry here, and there is no carry at the D7, but as you can notice, this one here indicates that the value is a negative, since this part, it indicates that the result is 20 when we subtract, for example, 50 minus 70 equals negative 20. So this solution is correct. So let's focus on the status register. So the carry we plug here, the C plug is 1, 0 plug is 0, and the negative plug is 1, and the overflow is 0, and the sign plug, as we can know, as the sign plug is the exclusive OR of the overflow and the end plug, or the negative plug. And there is also a half carry plug. For the third problem, we are also given here the code, and we will just also examine the status register. So as per the problem, we have to load the value from R20 to R23 using the LDI instruction, and to complement the values stored from R20 up to R23, we will use the COM instruction. So we will now simulate by clicking the F11 or step into. So LDI R20, 0. Then the value now of R20 is 00, and next R21 0xf 0xff, for R22 0x11, in R23 0x22. So now we will use the COM instruction to complement the values stored in R20. So if we hit F11, so the R20 has now a value of 0xFF, meaning uh, I will show you the solution I have made here. So when we complement the values of 000, we will have the 11111, 1111. Okay, so as we examine the status register, there is a carry at the D7 and the values are negative, which this indicates that the negative flag has a value of 1, and the sign flag, when we use the operation XOR of the V flag and the N flag. So B flag is 0, N flag is 1, so the XOR of this is 1. So sign flag indicates one value here. So next, we complement the 0xFF, so the value now of R21 is 000. So as you can see here in our solution, we just complement the values of 111 becomes 000 as its complement. And the status register, the carry flag is 1 and the 0 flag is 1, since the result after we complement is 0. So next, R22, the 0x11 will be complemented. So in the solution, as we look at here, 001, 0001. So we complement 1110, 1110, or 0xEE in hex. So the status register indicates the C plug is 1, 0 plug is 0, negative plug is 1, the overflow plug is 0, the sign plug is 1, the half carry plug is 0. Okay, next, let's complement the values from R23 or the 0x22. So in our solution here, we have 0010, 0010. We will have its complement 1101, 1101. Okay, so the status register indicates there is a carry. The value of C plug is 1, Z plug or the 0 plug is 0, since as you can see the result is not 0. So the N or the negative plug is 1, because as you can see here at the D7 bit indicates 1 or the negative. Then overflow 0, the sign plug is 1, then 0 from V and 1 from N. We do the XOR, then the result is 1. Then the half carry plug is 0. So the last problem, find the value of the C plug after the execution of the following code. So we will just examine the status register and focus on the C plug after the execution of these codes. So we hit a F11, so LDI R20 hex 85. So hex 85 is loaded immediately to R20. Hex 92 is loaded immediately in R21, and then we will add R20 and R21, then the result will be stored at R20. So as we examine the status register, the C plug here indicates that the value of C plug is equal to 1. So As we verify this by our solution, first I convert the hex value into binary. Then I perform the addition operation, and as you can see here, there is a carry over in the D7. So D0, D1, D2, D3, D4, D5, D6, D7, and this one is the carryover. So it is true. C is equals to 1. So next, we load immediate value of hex 15 to R16 and hex 72 to R17, and then we will add these two and store the result in R16, and then we will examine the status register. Let's focus on the C plug only. So C is equals to 0. Let's check or verify the result from our solution. So here D0, D1, D2, D3, D4, D5, D6, D7, and there is no carry here. So the C plug is 0, as we see here at the S reg. So true. So next, we load the F5 in R25 and 52 in R26, then we will add these two. So let's examine again the status register. The C now has a value of 1, and we will verify in our solution. So D0, D1, D2, D3, D4, D5, D6, D7, and there is a carry over here. So the C flag is 1. So true. Next, LDI R25 hex FE. So we use the increment. We increment twice the value of R25. So after we increment, there is a value of C here at the status register. C equals to 1 here. So after we click again, the value of C here is 1. So we go back to our solution. Here there is a carryover. So I think that's all. Have a good day, and thank you for watching.